Professor Vidian strode into the classroom with a newfound confidence after her previous successful lecture, though she remained wary of potential challenging questions. Her tentacle-like appendages carried a collection of holographic displays as she situated herself at the front of the diverse alien classroom on Novaterra. "Welcome back, everyone," she greeted, her irradiant skin shifting through subtle hues of blue. "Today, we'll be exploring lesser-known and often misunderstood aspects of human behavioral biology and life maintenance. I trust you've all reviewed the materials from our previous session." A silicon-based student in the third row raised what appeared to be a crystalline appendage. Unlike the organic students, this being had a body composed of intricate crystalline structures that occasionally emitted soft pulses of light. "Yes, Crystallex?" Ka acknowledged. "I conducted additional research on humans after our last session, Professor," the silicon-based student declared, voice resonating through the classroom like vibrating crystal. "And frankly, I'm even more horrified than before. Their dependence on continuous organic matter consumption, their inevitable decomposition processes, and what they call aging, there's clearly something fundamentally wrong with them." A murmur of agreement rippled through the classroom. Ka noticed several students nodding or exhibiting their species-equivalent gestures. She realized she needed to delve deeper into the most uncomfortable aspects of human biology that alien species found so alien. "I appreciate your candor, Crystallex," Ka replied, "and I understand many of you share similar sentiments. Today, we'll tackle these disturbing aspects head-on. Perhaps by understanding them better, we can see them not as flaws, but as fascinating evolutionary solutions." She activated her holographic display, which filled the classroom with a three-dimensional model of the human body, including detailed cellular structures. Let's begin with what many of you perceive as human fragility and their paradoxical resilience. The display zoomed in to show human cellular structures, immune system components, and DNA repair mechanisms in intricate detail. "Humans are indeed fragile in many ways," Ka acknowledged. "Their bodies can be severely damaged by temperature variations of merely 10 degrees Celsius. They require a precise mixture of atmospheric gases. They succumb to microscopic pathogens regularly. And yet," she paused dramatically before continuing, "they display remarkable resilience that often confounds medical expectation. For instance, my colleague Peter, yes, the human I've mentioned before, once suffered what should have been a catastrophic skiing accident. He broke 3 bones and tore several ligaments. Medical predictions suggested he might never walk properly again." Ka's skin briefly flushed a deeper blue at the mention of Peter, something that didn't go unnoticed by several students. 6 months later, he was not only walking but participating in a moderate hiking expedition. The human body's ability to repair and adapt is extraordinary, especially for an organic system that appears so vulnerable on the surface. A gelatinous student near the front, whose body constantly shifted and flowed within a semi-transparent membrane, raised a pseudopod. "Yes, Ka acknowledged. "But Professor, wouldn't a properly designed biological system avoid damage altogether? My Lorian physiology allows me to simply flow around potential injuries and reconstitute my form. Humans seem like they were hastily designed." "An excellent observation," Ka replied. "However, I'd suggest that rather than viewing humans as poorly designed, we might consider them as having different evolutionary priorities. Their ancestors required speed, dexterity, and fine manipulation skills over perfect durability. Evolution doesn't aim for perfection. It selects for good enough under the circumstances." She adjusted the display to show a panorama of human surgeries, organ transplants, and medical interventions. Furthermore, humans have developed remarkable technologies to compensate for their biological limitations. They can literally replace failing organs with those from other humans or, increasingly, artificial substitutes. They can surgically repair or reroute damaged systems. This ability to modify their own bodies through their intelligence and technology is, in itself, a form of extraordinary adaptation. A student with exoskeletal features clicked its mandibles in apparent disgust. But the physical repair process itself is so messy. The leaking fluids, the exposed flesh, it's revolting. Which brings us to our next topic. Ka smoothly transitioned. Let's discuss those revolting bodily fluids and their essential functions. The holographic display shifted to show the various fluids human bodies produced: blood, tears, sweat, saliva, mucus, and others. Several students visibly recoiled or displayed species-appropriate disgust responses. "I understand your reactions," Ka said, "but each of these fluids serves crucial biological functions. Blood transports oxygen, nutrients, and immune cells throughout the body. Tears protect the eyes and express extreme emotions. Sweat regulates temperature. Mucus traps pathogens." A student with bioluminescent features that pulsed with different colors raised an appendage. "Yes, Leah," Ka called on the Lorient student. "Professor, why do humans leak water when experiencing emotions? It seems inefficient to lose precious hydration because of psychological states." "An insightful question," Ka replied. "Tears serve multiple purposes. Basal tears continuously protect the eye. Reflex tears respond to irritants. But emotional tears, what you're referring to, contain different chemical compositions, including stress hormones. Some theories suggest crying helps regulate emotional states by physically releasing these compounds. Additionally, tears serve as a social signal, communicating vulnerability and the need for support from other humans. So they leak to communicate?" Leah clarified, her bioluminescence shifting to a curious yellow-green. "In a simplified sense, yes. Which leads to another point. Many human biological functions serve dual purposes, physiological and social." Ka hesitated before continuing, knowing she was approaching sensitive territory. This dual-purpose nature extends to various forms of human physical contact as well. For example, the pressing of lips or the exchange of saliva that humans call kissing serves both to assess genetic compatibility through chemical signals and to strengthen social bonds through sensory pleasure and oxytocin release. Ka noticed her skin shifting to a deeper blue, the irradiant equivalent of a blush, and quickly moved on. Let's address another aspect many species find puzzling: human sleep cycles and dreams. The display shifted to brain scans of sleeping humans, with colorful neural activity patterns dancing across the projection. A crystalline student, different from Crystallex, raised an appendage. Its voice resonated with a higher pitch, indicating its younger status among the silicon-based life forms. "Professor, I find it utterly inefficient that humans must become unconscious for approximately 1/3 of their entire lifespan. Moreover, during this state, their brains generate random hallucinations. How could such a flawed system evolve?" "Valid concerns, Silica," Ka acknowledged. "Sleep might seem wasteful, but it serves crucial functions for both brain and body maintenance. During sleep, the brain processes and consolidates memories, clearing metabolic waste that accumulates during waking hours. Physical systems repair and regulate themselves. Without adequate sleep, humans suffer severe cognitive and physical decline." She highlighted the dream cycles in the brain scans. "As for dreams, these random hallucinations, as you put them, while we don't fully understand their purpose, they appear important for emotional processing, problem-solving, and memory consolidation. Some humans report solving complex problems through dreams or gaining new creative insights. Their apparent randomness may actually be a feature rather than a bug, a form of neural network optimization through semi-random simulation." Ka paused, noticing the continued confusion and mild disgust on several student faces. "I understand that many of these processes seem inefficient or disturbing from your perspectives, but I encourage you to consider that what seems wrong or horrifying might simply be different evolutionary solutions to survival challenges. The human body, with all its apparent flaws, has enabled them to become one of the dominant species on their planet and expand beyond it." She gestured toward the windows, where the sprawling interplanetary port of Nova Terra was visible in the distance, ships of all sizes and designs arriving and departing. In our next segment, we'll explore the peculiarities of human senses and perception, which might help explain how they experience the world so differently from many of you. Several students quickly took notes or stored information according to their species methods as Ka prepared for the next section. Now, let's summarize what we've covered about the organic aspects of human biology before moving on to how humans perceive the world, another area full of peculiarities by interspecies standards. Ka adjusted the holographic display, which now showed a human head with highlighted sensory organs. Humans possess a relatively restricted visual spectrum, yet their visual processing is remarkably specialized for certain tasks, she began. The display zoomed in on human eyes and brain visual centers, comparing the human visual spectrum with those of various other species. Unlike many species, humans cannot perceive ultraviolet or infrared light. Their visual range is quite narrow, spanning approximately from 380 to 700 nanometers. By comparison, the Zethyian mantis shrimp can perceive 12 primary colors compared to our 3, and many of you have visual ranges far exceeding the human capacity. A multi-eyed student in the back raised several appendages simultaneously. Then how do they function with such limited perception? The student asked, compound eyes blinking in sequence. Excellent question, Optex, Ka replied. While limited in range, human vision is exquisitely tuned for specific purposes, primarily social interaction, threat detection, and food identification. Human visual processing devotes extraordinary resources to facial recognition and emotional detection. They can distinguish between thousands of subtle facial expressions and interpret emotional states with remarkable accuracy from minimal visual cues. The display showed examples of human facial expressions. This leads to an intriguing phenomenon called pareidolia. Humans see faces everywhere, even in inanimate objects. Peter once showed me a piece of charred bread where he perceived a sad face in the burn pattern. He refused to eat it because it looked too depressed. Several students made sounds approximating laughter. This heightened pattern recognition, especially for faces, was crucial for human survival and social cohesion. It helps them rapidly assess potential threats, allies, and the emotional states of their peers. A student with a spherical body covered in optical sensors rotated slightly. But isn't this inefficient? My 360-degree vision eliminates blind spots completely. Humans seem intentionally designed with perceptual vulnerabilities. Your visual system evolved for your species' needs. Panoptica corresponded. Humans evolved as pursuit predators and social creatures. Their forward-facing eyes provide excellent depth perception and movement tracking, crucial for hunting and tool use, at the cost of peripheral vision. No perceptual system is perfect. Each reflects evolutionary trade-offs. Ka transitioned to the next topic. Now, let's explore perhaps the most enigmatic of human senses, smell and taste, which connect directly to memory and emotion in ways many species find baffling. The display showed the human olfactory system and its neural connections to the limbic system. Human olfaction is actually quite sophisticated, capable of distinguishing thousands of distinct scents. However, what's truly remarkable is how inextricably linked these senses are to memory and emotion. Ka referenced brain scans showing activity patterns. Olfactory information bypasses normal processing channels and connects directly to the human amygdala and hippocampus, centers for emotion and memory. A single scent can instantly trigger vivid memories and powerful emotions from decades earlier, a phenomenon humans call the Proust effect after an author who described it eloquently. The student named Soha raised a pseudopod again. Professor, I've observed humans deliberately covering themselves with artificial scents that seem to have no survival value. And some even consume fermented, decaying matter that produces strong odors. Is this pathological behavior? Ka's skin rippled slightly in amusement. Not pathological, but culturally and biologically complex. The artificial scents, perfumes, often mimic or enhance natural human attractants, serving social and reproductive signaling functions. As for fermented foods like certain cheeses or kimchi, humans have developed cultural preferences for controlled decay processes that produce complex flavor compounds and preserve nutrients. What might smell like rot to you contains subtleties humans find pleasurable and beneficial. A predatory-looking student with heightened sensory organs leaned forward. How do they tolerate their own scents? When I was stationed on a human vessel, the odor was overwhelming. Sensory adaptation venera geëxplained. Humans quickly habituate to constant stimuli. Their olfactory neurons stop firing in response to persistent scents, effectively becoming noseblind to familiar odors, including their own. This adaptation preserves sensory bandwidth for detecting new, potentially important scents. Move to the next subject. This brings us to auditory perception and humans' unique relationship with structured sound. Music. The display showed the structure of the human ear and auditory cortex, along with waveform representations of music. Human hearing ranges approximately from 20 to 20,000 hertz. Again, more limited than many species. However, their auditory processing demonstrates extraordinary pattern recognition, emotional association, and memory formation capabilities. She played a brief segment of orchestral music. Many students reacted with confusion, discomfort, or indifference, though a few showed signs of interest. This seemingly random collection of vibrations can induce profound emotional responses in humans. Different musical structures can reliably produce specific emotional states across various human cultures. A capability that evolved primarily for language and threat detection has become a fundamental aspect of human culture and emotional experience. A student who communicated primarily through electromagnetic field modulation raised an appendage. Professor, this seems extraordinarily inefficient compared to direct thought transmission. Human vocal communication is imprecise, easily misunderstood, and limited by physical distance. Why would an allegedly intelligent species rely on such a flawed system? While telepathic communication has clear advantages, waveform, vocal language offered early humans critical evolutionary benefits, Ka explained. It works in darkness, around obstacles, and allows communication while maintaining visual attention elsewhere. Moreover, the very ambiguity you criticize creates rich possibilities for linguistic creativity. Metaphor, storytelling, poetry. Ka played a brief recording of a human reading poetry. The rhythm and emotional cadence were evident even to those who couldn't understand the words. This inefficient system allowed humans to create works of extraordinary beauty and complexity. The poem I just played explores concepts of mortality and transcendence through carefully structured ambiguity that would be difficult to achieve through direct thought transfer. Ka noticed the time and moved to her final sensory topic. Let's briefly discuss the sense perhaps most alien to many of you: touch and the human need for physical contact. The display showed the distribution of various touch receptors across human skin. Humans possess an exquisitely sensitive tactile system. Different receptor types detect pressure, temperature, texture, pain, and pleasure. But beyond mere information gathering, physical touch plays a crucial role in human development and well-being. Several non-corporeal or differently embodied students shifted uncomfortably. Human infants who receive inadequate physical contact, even when all other needs are met, show developmental delays and psychological distress. Throughout life, appropriate physical contact releases hormones that reduce stress and build social bonds. Hugs, handshakes, pats on the back. These seemingly simple touches carry complex social meanings and physiological benefits. For species without similar tactile systems, this may seem strange or even disturbing, but for humans, touch is a fundamental language of care and connection. A student composed primarily of electromagnetic energy contained in a specialized field emitter raised a glowing appendage. Is this why human Peter often touches his face or hair during your joint research sessions, Professor? I observed this behavior during my lab rotation. Ka skin flushed deeply blue. Yes, Lumina, self-touch can indicate comfort-seeking or stress management. It's a normal human behavior, she said, quickly moving on. To conclude this section, while human senses have clear limitations compared to many species, they are precisely calibrated for the complex social interactions, emotional experiences, and creative expressions that define human existence. Next, we'll examine the emotional roller coaster that many find most perplexing about humans. Ka paused to allow students to process the information before continuing. Now we enter perhaps the most challenging aspect of human biology for many non-human species to comprehend: their emotional landscape. The display shifted to show brain scans highlighting various emotional states, with complex neural and chemical interactions displayed in vivid detail. Humans experience an extraordinarily wide spectrum of emotions, from profound joy to devastating grief, with countless nuances between. Their emotional capacity extends far beyond simple survival mechanics of pleasure and pain. The image zoomed in on the neurochemical processes of several emotional states. The neurobiological basis of human emotions involves complex interplays between brain structures like the amygdala, prefrontal cortex, and hippocampus, along with neurochemicals including dopamine, serotonin, oxytocin, and dozens of others. A student with highly logical thought patterns, visible through the transparent cranial structure that housed their pulsing brain analog, raised an appendage. Professor, I understand basic emotions like fear and aggression as survival mechanisms. But what evolutionary purpose could emotions like existential despair or nostalgia possibly serve? They appear to be malfunctions rather than features. An insightful question, Logix corresponded. These complex emotions may seem counterproductive, but they serve subtle yet important functions. Take grief, the profound sadness following loss. While painful, it reflects the strength of social bonds that were crucial for human survival. The capacity for deep attachment motivated humans to protect their social groups, even at personal cost. She displayed examples of human creative works born from complex emotions. Furthermore, these malfunctions, as you call them, have driven extraordinary human achievements. Great art, scientific breakthroughs, philosophical insights. Many emerge from experiences of suffering, uncertainty, or yearning. Human emotional complexity fuels their creativity and resilience in ways we're still trying to fully understand. A student near the front with a hive mind consciousness, represented by thousands of tiny, interconnected organisms forming a collective entity, emitted a synchronized pattern of light. But Professor, the physical manifestations of these emotions seem so disruptive. Laughter paralyzes their respiratory systems. Crying depletes valuable water resources. Why would evolution select for such seemingly self-sabotaging behaviors? Excellent observation. Toletve karepliet. These physical manifestations may appear counterproductive, but they serve important functions. Laughter, for instance, releases tension, signals non-threat, and strengthens social bonds through shared experience. It triggers endorphin release, reducing stress and pain. What looks like a respiratory malfunction is actually a sophisticated social and physiological regulation mechanism. She switched the display to show the hormonal changes associated with crying. Similarly, emotional tears contain stress hormones and natural painkillers. The act of crying not only removes these compounds from the body, but signals vulnerability to others, often triggering caregiving responses. What appears wasteful is actually a complex stress regulation and social signaling system. Ka remembered a personal anecdote. Peter once described an experience where he laughed until he cried at a friend's wedding. When I asked why experiencing joy would trigger tears, a seemingly contradictory response, He explained that the intensity of positive emotion occasionally overflows into the same physical channels as distress. Human emotions aren't simply discrete states, but exist on complex, sometimes overlapping continuums. A student with neural networks distributed throughout their transparent body raised what approximated an arm. Professor, is this why humans engage in behaviors that seemingly contradict their own interests? I observed a human watching a dramatic narrative entertainment that induced visible distress, yet they described the experience as enjoyable. Precisely, Nura, Ka confirmed. Humans often seek emotional experiences that appear negative because the complexity of the experience itself is valued. They call it catharsis, the purging or processing of emotions through artificial experiences. This capacity to find value in the full spectrum of emotional experiences, even challenging ones, is actually an advanced adaptation rather than a flaw. She moved to the next topic. Let's explore one of the most fascinating aspects of human neurobiology, their capacity for empathy, literally feeling others' emotions. The display showed mirror neuron systems lighting up in brain scans. Humans possess specialized neural networks that activate similarly whether they experience an emotion directly or observe it in others. These mirror neurons create a neurological basis for understanding others' experiences. A human watching another in pain will experience partial activation of their own pain centers. A student with a collective consciousness spanning multiple bodies spoke up. This seems inefficient compared to true mind-melding, Professor. Why simulate another's experience imperfectly when direct consciousness sharing would be more accurate? While consciousness sharing offers perfect information transfer, multiform, empathy offers different advantages, Ka explained. It maintains individual boundaries while still facilitating cooperation. It allows humans to understand entities extremely different from themselves, including non-human animals and potentially even artificial intelligences or alien species. This flexibility potentially makes empathy more adaptable than direct consciousness sharing in diverse environments. Ka noticed her time was running short and moved to the final emotional topic. Before we conclude this section, we must address what many consider the most bewildering aspect of human emotions: romantic attachment and what humans call love. Several students leaned forward with increased interest. Human pair bonding involves complex neurochemical processes beyond mere reproductive imperatives, Ka explained, her skin shifting through subtle blue patterns. Hormones like oxytocin and vasopressin create powerful attachment bonds that can override self-preservation instincts. Humans routinely prioritize their bonded partners' well-being above their own, sometimes at significant personal cost. The display showed brain scans of humans in various stages of romantic attachment, highlighting activation in reward centers similar to addiction patterns. From an evolutionary perspective, these powerful bonds ensured parental investment in highly dependent offspring. But they've evolved into complex emotional attachments that extend far beyond reproduction. Humans form these bonds across reproductive boundaries with individuals of the same sex, different ages, or even between species in the case of companion animals. A familiar Lorian voice spoke up. Professor, would these attachment mechanisms explain why a distinguished Iranian xenobiologist might form a bond with a human spacecraft pilot despite vast biological differences? Asking for academic clarity, of course. Ka's skin instantly transformed to a deep indigo, the Iranian equivalent of an intense blush. Several students made their species equivalent of knowing looks or suppressed laughter. The neurochemistry of interspecies relationships remains an understudied field, Leah, Ka stammered, struggling to maintain her professional composure. But yes, in theory, similar mechanisms could potentially, hypothetically. Let's move on to our concluding section about human motivational systems. The classroom filled with various sounds approximating laughter as Ka hurriedly changed the display. Having explored human physiology, senses, and emotions, we now face the ultimate question: what drives humans? What motivates their often contradictory behaviors? The classroom had settled after the previous moment of humor, and students returned their attention to the holographic display, which now showed a complex web of interconnected motivational systems. Humans demonstrate a seemingly innate need for purpose and meaning that extends beyond basic survival. Ka began. While all sentient species seek to continue existing, humans appear uniquely preoccupied with why they exist. The display highlighted various human cultural creations, religious icons, philosophical texts, scientific discoveries, and artistic masterpieces. This search for meaning has produced religion, philosophy, art, and scientific inquiry. Humans dedicate enormous resources, material and cognitive, to questions that have no immediate survival value. Many spend their entire lives pursuing abstract concepts like truth, beauty, or justice. A student with a highly pragmatic species background raised an appendage. Professor, isn't this simply a malfunction? A processing error that diverts resources from reproduction and survival. One might think so, pragmatics, Carr replied. However, this malfunction may actually be adaptive. Meaning-seeking behaviors strengthen social bonds, motivate innovation, and help humans persevere through hardship. Societies unified by shared purpose regularly outcompete those without such cohesion. She transitioned to the next motivational aspect. Closely related is human ambition, their drive not just to survive but to exceed previous limitations, both individual and collective. The display showed historical human achievements, early tools, architectural wonders, space exploration vessels, and medical innovations. Human history is largely defined by their continuous efforts to transcend boundaries. They're rarely satisfied with sufficient. They persistently seek improvement, expansion, and novelty. A student from a highly cooperative, eusocial species raised several appendages in evident distress. But Professor, this same drive has caused terrible destruction. Their historical records document endless conflicts, environmental damage, even species extinctions, all driven by this ambition you describe. Isn't this clear evidence of fundamental biological error? Your concern is valid, Harmonia, acknowledged. Human ambition is indeed a double-edged molecular blade. The same drive that creates medical breakthroughs also creates weapons. The impulse to explore leads to both discovery and exploitation. Technology that can heal can also harm. She adjusted the display to show balanced examples of both positive and negative outcomes of human ambition. However, I would suggest this isn't necessarily a design flaw, but rather a powerful adaptation with high variance in outcomes. The capacity to imagine and strive for different possibilities, what humans call hope, has enabled survival under extraordinarily adverse conditions. Without this sometimes destructive drive, humans might have remained limited to a single ecosystem rather than adapting to environments across their planet and beyond. Ka moved to her next point. This brings us to humans' most distinctive feature, their extraordinary creativity. The display cycled through examples of human creative expression: architecture, music, literature, art, technological innovations, and scientific discoveries. Human creativity extends far beyond problem-solving. They create for creation's sake. They imagine possibilities that don't exist and then bring them into being. They combine concepts in ways that defy predictive algorithms. She played brief examples of human music, poetry, and displayed several art pieces. This creativity stems from their unique neural architecture, which excels at pattern recognition, abstract thinking, and conceptual blending. Their associative cortices make connections between seemingly unrelated domains, generating novel insights and expressions. A student with highly logical thought processes visible through their transparent cranium signaled again. Professor, isn't this simply an epiphenomenon of their pattern recognition systems? A side effect rather than an adaptation? Perhaps initially, logics, Carr replied, but this side effect became central to human survival and flourishing. Creative solutions to environmental challenges, social organization, and resource management gave creative individuals and groups significant adaptive advantages. What may have begun as neural noise became a defining feature of human cognition. Ka's expression grew more serious as she approached her final topic. We must also address the darker aspect of human motivation, their capacity for self-destruction and addiction. The display showed brain scans of addiction processes, self-destructive behaviors, and risk-taking activities with minimal survival value. Humans regularly engage in behaviors that harm their own biological interests. They consume substances that damage their organs, take unnecessary risks, develop harmful obsessions, and sometimes deliberately end their own lives. Murmurs of concern spread through the classroom. These tendencies stem largely from reward system vulnerabilities. The same dopamine-based motivation systems that drive survival behaviors can be hijacked by substances or activities that provide immediate reward without adaptive benefit. A student whose species had overcome biological limitations through technological integration spoke up. "Surely this represents the clearest evidence of flawed design, Professor. How can such self-destructive tendencies possibly be explained except as biological error?" "It's certainly tempting to view it that way," Technos acknowledged. "And from a purely survival optimization perspective, these vulnerabilities are problematic. However, the same reward system flexibility that creates these vulnerabilities also enables humans' extraordinary adaptability and learning capacity." She highlighted the neuroplasticity of human reward systems. Furthermore, many humans recognize these tendencies and actively work to overcome them, creating support systems, therapeutic approaches, and cultural practices that mitigate these risks. Their awareness of their own vulnerabilities and capacity to address them is itself a remarkable adaptation. Ka looked across the classroom, noting the mixture of confusion, fascination, and lingering judgment on various student faces. As we conclude this section, I want to emphasize that human motivation is neither simple nor singular. These sometimes contradictory drives for meaning, achievement, creativity, and even self-destruction create the dynamic tension that defines human experience and potential. She prepared for her final summary section. We've now completed our exploration of human biology's apparent problems. Let's try to synthesize what we've learned and address our original question. What, if anything, is truly wrong with human biology? The classroom atmosphere had shifted to a more contemplative mood. Students adjusted their positions, prepared to take final notes, or simply focus their attention in their species-specific ways. Ka began her conclusion with a thoughtful tone. Throughout these lectures, we've examined numerous aspects of human biology that seem problematic from various non-human perspectives. Their physical fragility, yet strange resilience. Their messy bodily fluids and peculiar maintenance requirements. Their limited but specialized sensory systems. Their chaotic emotional landscape, and their contradictory motivational drives. She paused, letting the comprehensive scope of their exploration sink in. I propose that humans might be viewed as something of an evolutionary experimental package, combining traits that might seem incompatible. Physical vulnerability with cognitive flexibility, logical rationality with profound emotionality, selfish impulses with remarkable altruism. The display showed an integrated model of human systems working together. What appears as flaws in isolation often reveal themselves as necessary components of an integrated system when viewed holistically. Their physical vulnerability encouraged tool development and social cooperation. Their emotional reactivity strengthened social bonds and creative problem-solving. Even their mortality, perhaps their most lamented flaw, creates the urgency that drives much of their achievement and meaning-making. Ka moved to her next synthesis point. Equally important is understanding that humans aren't solely determined by their biology. Their consciousness, learning capacity, and cultural systems allow them to recognize their limitations and create solutions that extend beyond their physical constraints. The display showed examples of cultural adaptations and technologies that compensate for biological limitations. Medical science to overcome disease and injury. Social norms to regulate destructive impulses. Art and philosophy to process emotional complexity. Technology to enhance natural capabilities. Education to bypass trial and error learning. She highlighted the progression of human technologies. In many ways, the story of human civilization is the story of transcending biological constraints through collective intelligence and accumulated knowledge. Rather than being defined by their limitations, humans have made overcoming those limitations central to their identity. Ka invited final thoughts from a class. I'd like to hear your perspectives now. After these lectures, has your understanding of human biology changed? Crystalex, the silicon-based student who had expressed such horror at the beginning, spoke first. I still find organic systems inefficient, Professor, but I better understand the adaptive trade-offs. Their integration of seemingly contradictory elements is not without elegance. Soha, the Lorian, contributed next, their gelatinous form rippling with amusement. I've come to appreciate what I'd call their organized chaos, Professor. There's something almost poetic about how their limitations and strengths intertwine. Other students offered their observations, each reflecting their species' perspectives, but generally showing increased understanding and less judgment than before. Finally, Leah, the Lorian student who had teased Ka about Peter, spoke up once more, but with a more thoughtful tone. Professor, I wonder if their very messiness might actually be their greatest strength when it comes to interspecies understanding. Their experience of navigating their own contradictions perhaps prepares them to comprehend wildly different forms of life. Like us. Ka nodded appreciatively at this insight. Even Hissa, a normally judgmental student, offered a grudging acknowledgement that humans were at least more interesting than initially assessed. As the discussion wound down, a final question came from a previously quiet student in the back. Professor Vidian, after everything we've covered, do you believe the problems in human biology outweigh their strengths? Ka paused, considering the question carefully. The classroom fell silent in anticipation. That's not quite the right question, she said finally. Human biology, with all its complexities and contradictions, simply is what it is. It has allowed them to survive, thrive, build civilizations, create art, develop technology, and eventually reach the stars. Their biology has carried them from caves to space stations within a cosmically brief time span. She continued, her voice thoughtful. What we perceive as wrong or right depends entirely on perspective and criteria. By efficiency standards, humans are indeed problematic. By creativity standards, they're extraordinary. By adaptability standards, they're remarkable. By durability standards, they're concerning. Ka's skin shifted through subtle patterns of blue as she concluded. Perhaps what makes humans most fascinating and what has made teaching about them so rewarding is precisely this amalgamation of contradictions. They are simultaneously fragile and resilient, rational and emotional, selfish and selfless, destructive and creative. Understanding them requires embracing paradox rather than insisting on consistency. And maybe, just maybe, that's a valuable lesson for all sentient life, regardless of our biological composition. The class ended in thoughtful contemplation. Students departed with new perspectives and perhaps fewer prejudices than before. Ka remained alone in the classroom, smiling to herself as she organized her materials. She checked her communication device and found a message from Peter. How'd the What's Wrong with Humans lecture go? Did you defend our leaky, sleep-dependent, emotionally chaotic species with honor? Dinner later to celebrate surviving another semester? Ka's skin rippled with amused patterns as she typed a response. Teaching about humans had indeed become a journey of self-discovery. As she left the classroom, she felt a renewed optimism about the diversity of sentient life throughout the universe and each species' place within it, including the endearingly problematic humans. Even as an accomplished xenobiologist, Ka realized she was still learning that what initially appears as biological Wrongness across species might simply be beautiful difference. And that recognition, she thought as she headed toward her meeting with Peter, might be the most valuable scientific discovery of all.